Hi, it's cheap oscilloscope time again because FNIRSI keeps sending these things into the mailbag. In fact, they sent two. They sent another one of this with the transistory tester thing. You've seen that before, but I'm not going to do that in this video. They keep sending them in, but people seem to like the value for money proposition in these low-cost portable scopes, and the videos on these seem quite popular, so I don't know, let's take a look at it. 2-in-1 digital phosphor oscilloscope, not that monochrome rubbish. Now we get color intensity graded display, high voltage anti-burn-in protection, because it's important that your oscilloscope doesn't burn. 5 millivolts per division high sensitivity, 180 megahertz analog bandwidth, we'll see about that, 500 meg samples per second, and this currently is on special at like 40% off, granted, for 137 Yankee bucks, or 217 Aussie bucks on special. So let's take a look at it. I mean, we've looked at various FNIRSI ones before. Sorry, I pronounce it FNIRSI. Some people pronounce it FNIRSI. I think I called it that when I first, I don't know, whatever. But they're basically, the summary of these things has always been overpromised and underperformed. That's pretty much been the verdict on the previous ones. But you know, you do get a lot of potential bang for your buck. So let's take a look at it. It's obviously a dual channel, so we've got two 200 meg switchable probes there. They look okay. We've got ourselves a manual. That looks reasonable, actually. So, I don't know. Yeah, USB-C. So it's going to be USB-C rechargeable. We do get a cheapy plug pack, so yeah, don't trust these things any further. They can throw it. One of these Yankee plugs, so that's no good for me. But you know, standard USB-C. So seal for our protection. Let's have a squiz, and look what we get here. Where's the blue? Yeah, blue on there, but we got like a fluke yellow. So anyway, so we've got screen protector on there. So will this thing overpromise and underperform? Well, there's only one way to find out. Is it charged? Can we turn it on? There you go. And wow, that's a quick boot. That's nice. I like that. Let's do that again. Can I just press it once? Now, a problem with that, that's really good. A problem with that, of course, is that you could easily bump that if, you know, because this is portable, put it in your tool bag or whatever, and you could easily bump that power switch. So I'd like to see some ability to lock that out. But standard BNC inputs, non-isolated, of course, and it's got a Sig Gen there. I'm not sure how useful a Sig Gen is with just a pin in it like that. It's not really a useful interface, but okay. Physically, this thing is quite cute. You know, we've got the rubber baby buggy bumpers around here, and that's all pretty good. And we've got this huge tilting bail at the back, like that. So, you know, it's not falling over anytime soon, so that's pretty groovy. Well, I'll tell you what, that screen is really bright. I've got my Bright Studio lights on here, and that is, like, the angles on that are really good. So yeah, no worries whatsoever. Now, layout wise, they've changed it again. We haven't seen this before. Volts per division, up and down, but we don't know which channel we've actually selected there. How do you select which channel you want? That's non-obvious, is it? Channel 1, but how do I get rid of that? But like, it doesn't show which one is actually selected. So, like, I can press channel 2. No, I don't like that at all. Like, I like the menu's really nice. Anyway, you might think T might be for time base here. It's not. It's for your trigger level, but that's okay. H is your time base for your horizontal, like that. Okay, no worries. It's all fairly responsive. Can we just move with, yeah, that's actually really quite responsive. I like that. And we've got measurement, so that'll whack up measurements. We've got menu over here, all sorts of stuff. It's a really bright display. I really like it. So what does move mean? Slow movement or fast movement? I think they mean updating, right? Anyway, let's whack a signal in this because we can't do much else. So I still haven't figured out how to move channel 2. How do I select any channel 2? It's not touchy-feely. Okay, original. That's just like, looks like it just reset everything. Channel enable, on, off. Okay, so we can probe attenuation. Okay, probe coupling. FFT display, hard bandwidth limit. All right, I've plugged in my Leobud pulse generator here, so let's see if we can do auto, shall we? We'll automatically adjust. Will we get our square wave? Yeah, we do. There you go. It's a bit of trigger jitter there, but anyway, let's go up a division, and then we'll move that 200 millivolts, 500 millivolts per division. There you go. There's our trig level. We can set that to 50%. We can move it around. It's doing the business, but there's quite a bit of jittery on there. Wow, look at that. I mean, that's jumping around like a jackrabbit. Look at it. I mean, the waveform updating seems fast. It's supposed to have 50,000 waveform updates per second, but anyway, it is measuring our 10 megahertz there, so no wuckers. So we can do that, and then we can go slow movement. Ah, there you go. That's what the slow button does. Oh, okay. Nice. Okay, fast movement. Okay, that's good. I like that. Okay, so we'll stop that. And, oh, there we go. We can see our sample points there. Expand like that. There you go. You can see that's interesting how it sort of gave the dots, but there is that's the color intensity graded display. No, that's the fastest time base we can get, actually. There you go, 5 nanoseconds per division. No, we can see our samples there. That all seems to be working nicely. I rather like that. And I'm not sure if it's showing up on screen, but there is really a faint line on there, so it's not just dots. We're not in dot mode. Check it out. There you go. It is jumping around like an absolute jackrabbit. And of course the pulse response on that is certainly not the best. I mean, that's just, look at that. Wow, that's look at it. 500 meg samples per second supposedly, but look at the jitter out here. Anyway, measurement menu on, parameter measure, channel 1, and we can go from channel 1 to channel 2, so we can have different measurement parameters. You can see them ticked over here. Can we jump over there? How do we jump from there to there? That is non-obvious. How does that work? You can see that we're getting some crosstalk onto channel 2 there. Granted, channel 2 is down at 5 millivolts per division, so, you know, you can forgive that, especially on such a low-cost scope like this. But it's only there if we overload it. Check it out. So if I go below, we get no coupling, but we go above, boom. So that's coming back through the supply rail of, yeah, something's happening with the input amplifiers, and that's coming back through the supply rail, I'd say, and being picked up on the second channel. Not a big deal, but it's there. Anyway, it does have a zoom mode. Look at that. There you go. So we're expanded in. We can move our window like that. Can we adjust? No, we can just move that up and down. So the horizontal changes once you're in zoom mode and you're out. So if we go like that and then we zoom and then we're in, then we can zoom in more like that. Okay. And then move it. That's working nicely. No, it's exactly the same in the center there as it is right out over there. So, yeah, that's not terrific, is it? Aha! And look at it, significantly drop down when I turn off channel 2 there. If I turn channel 2 back on there, it's back. Oh, I finally figured it out. How to change to channel 2. Look, channel 1 up there, you press mod OK, and that's your channel 2 selector. Look. But it doesn't show like a visual highlight down here. You got to look up there. That was so non-obvious. Anyway, check it out. There's actually quite a lot of capability in here. You've got system settings. You can set transparent menus, and you can have USB sharing mode. What is that? Does it output power or something? Automatic shutdown, factory settings, disk format. We can turn on horizontal and vertical cursors. We can do parameter measurement, and I have figured out this menu. It's the OK thing again. So you go OK, and then you can choose channel 1 or channel 2, and then if you want to go over there, you choose OK, and then that goes over there, and we can turn on like RMS, for example, and we could have min, max. So now There you go. We jump back here and we've got all those extra parameters up there. It'll continue to fill them up and you get less and less window space, of course, but you know, it's quite nice. We've got a data browser, so you can actually save the screen at any time, which is save P here, and it just saves the screenshot. That's really quite nice, and it works even in any mode, any menu system or whatever, so that's really quite neat. Now this is interesting. Capture output. Cut out a part or whole part of the current waveform signal and save it as an output on the signal generator. So I'm in channel 1 mode now, okay? If I store that, can I do the capture output thing, cut out that, right? So now it's, look, we can, this is really quite neat. Look at this. Wow, this is fancy pantsy, right? So I can cut this out. Can I do the move thing and make it slower? Yeah, look at that. I'm actually liking that. Now, how do I change to the next menu over? Oh, that one over here, is it? How do I change that one? I don't know. No, I've done it. Okay, I've captured it. I'm going to see if we're outputting anything. So, no, that's just the Sig Gen. But where's our capture output? Okay, mate, is it too high a frequency? Cut out a part or whole part of the current waveform signal and save it as an output of the signal generator. Is that that's just a 1 kilohertz square wave? That's not what the waveform we captured. So I don't know. And then cursor over there. Okay, there you go. Let's go up. We can go up to a megahertz. There you go. It instantly adjusts up to a megahertz. But can we adjust the horizontal? While we're doing that? No, we can't. We've got to go out of gen mode, but that's all right. There we go. Right, and let's trigger off channel 2. So trigger mode, auto, rise in, trigger channel 2. There you go. It just froze. Well, it locked in, and you go outside of the range. Yep, you go just outside, so the trigger value seems to be pretty accurate there. Okay, it looks like we have significant DC offset on that signal there. You can see where the ground is. You can see up there where it's, it's quite off. I need to change the trigger back. So yeah, why do we have that DC offset there? Is that really there? There is no ability to set DC offset there. So is that, like, I've got to assume it's really there. I mean, that's not good if it's actually there. Like, that's significant. We're 200 millivolts per division. We've got like 250 millivolts offset or something. I'll verify that on a real scope. Sure enough, that's got a huge offset. That's like 400 millivolts offset there. Why does it have an offset? That's nuts. And check out all this burst noise on here. And no, that's not because this scope isn't grounded. I can ground this. And we can go to my crazy fast update in MXO4 over here, and you can see that. Look at the noise on there. Unbelievable. So like, we can stop that. We can see that that's just picking up all sorts of crap there. That's picking up, like, is that like common mode stuff from my lab here? It probably is, right? It's picking up all this burst stuff, but it's on the Sig Gen output. I would not have expected that. There's the sine wave. Look, and there's just so much noise on that waveform. It's just triggering like buggery. Okay, I cleaned that up a bit with some RF rejection on the trigger there. But, oh, goodness. Yeah, nah. And absolutely no amount like of system grounding actually fixes that. I've used another totally floating scope here, this Mixig, and we're getting basically the same thing. You can see that there. So, and I don't see a way to adjust the signal level, the output signal level on this thing. So just pretend this thing doesn't have a signal generator. It's useless. Anyway, with the totally non-usable just pin like that for the output, I'm just going to ignore that. Just, no. Just imagine this thing just does not have a function generator. There's just no point. And technically, it does show an FFT here, but really you can't do anything with it, so it's nothing more than a toy. Well, I must say it's got a rather nice intensity graded display there. Got the 100% modulation 1 megahertz signal there. It's having a bit of trouble triggering on that, as a lot of scopes do, so that's okay. And if you want to adjust that, of course, you've got to go into the menu over here, and you've got to go over, and you can't really see it in the background, so you don't really know what you're getting. That's 8%, and that's 96%. There you go. So it does work. And well, there's 100 megahertz. Watch what happens if I turn channel 2 on though. It's gonna go wobbly. Look at that. Whoa. Okay, let's just check the amplitude here. We've got RMS 916, 913, 14. So yeah, it's basically bang on. That's 1 megahertz. 10 megahertz, 920 versus 940 there. Okay, so at 100 megahertz there, we're looking at, let's say 910 millivolts. And here, just to eliminate any probing, we're talking 953 millivolts RMS, so significantly over. Okay, I've got 140 megahertz there, and it's showing 1.24 volts there. And if we plug her in, 1.24, 1.04. So yeah, nah. Anyway, if we were 150, 160, 170, 180. So it looks like it does have its claimed 180 megahertz bandwidth. Oh, there we go. We've hit some alias in there. It doesn't like that at all, but we can actually go up to exactly 250. You can see that that's a beat of the sample rate there. So yeah, so it does technically have its 180 megahertz bandwidth. There it is, 916 millivolts. And should be 860, so, you know, look, you can't expect this to have the claimed 180 megahertz bandwidth. Like, it's not what you buy it for. It's going to be not flat. The front end's not going to be great like a proper scope, etc. It's built down to a price, so just, I don't even know why they bothered, like, speccing it up that high. It's just, yeah, it's kind of pointless. All right, let's do a quick tear down, see what's inside this puppy. I did get the screws out, so how do we... Is a spudger required? Spudger may be required. Sure, I unscrewed it. That's what she said. You got to peel those. Oh, you got to peel those back, do you? Holster's real. Look, you can see the holster's really integrated with that. Jeez. Geez, the case designer had a field day on that. Here's our battery. Geez, that was fun, wasn't it? The 11.1 watt hour jobby there. You could easily replace that if it gets a little puffy. But there you go. That looks pretty nice, doesn't it? 2 metal cans for the front end, but like I said, like, why do you need 180 megahertz in something like... You don't. This thing's built down to a price, so yeah, nah. What's that? What's an EF2L45LG? Oh, if I can find the info, I'll put it up there. 500 meg samples per second, 180 megahertz. They like to claim these banner specs, and oh, look. Oh, come on, the ADCs. Come on, just tell us what ADC you use. Seriously? They've just laser etched those off. Anyway, we've got some trace length matching there. There you go. So, you know, they've done the proper business there with the PCB layout. No worries. So, yeah, are they just off-the-shelf TI jobbies or something? Okay, what's the all-winner F1C 100S? Well, by the looks of the location here with the ribbon cable, that's going off to the LCD. Not much else. There's another Winbond parts upside down. All the electrons are going to fall out. So that'd just be an I2C prom, would it? And IP2312, that looks like a switching converter. There's your 24 megahertz clock there. More power stuff up here. No worries. So it all looks nice. Nice and tidy. 25 meg over here, so we've got a 24. Okay, so the 24 is for the all-winner, and the 25 over here, there you go, that's for the main processor here. Another laser-etched part? Seriously? An 8-pin SO? Come on. Lots of discrete trannies down there. Some more over here. That's possibly local, that'd be local voltage regulation for the analog front end, so that's rather interesting. What is that arrangement? It's almost as if like they got like 4 regulators there? No, surely not. Anyway, there's our USB, and on the other side as well. It's interesting. Okay, nothing else doing down there. We've got multi-color shot down there. There's your LCD. No. It's just plain label. And the bottom of the board, absolutely nothing. There you go. But they do have, look, they're going for a shield over the BNC there. Why have they gone to that effort? Nice attention to detail, but this is not going to be a high-performance analog front end. So, I don't know, but like they're at least taking it seriously. There we have it. There's under the cans. Relay down there. And is that a classic 4051? There you go. You always find a 4000 series mux in there. No worries. Don't know what that 8-pin part there is. That's interesting. Is that an input amp? There's an input can. And you notice our input must be under. Must be under there. So it must be on the inner layer. That's interesting. But there's a couple of unpopulated parts there. Now I'm going to have to look up some of these parts. Like they've got a huge number. These SOT23s, 3 EM there, and these two 8-pin SOs seem to be doing the amplifying work. There's a 6-pin SO, another little tiny 6-pin, 5-pin jobby, another 6. It's interesting, is it not? Well, there you have it. Those 3 EM parts, these seem to be, well, don't know if they're genuine on semi, maybe they're equivalent parts, but they're VHF, UHF transistor, NPN jobbies. Yeah, so there's a whole bunch of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them. Wow. And the others are A13, Y2. And the RS622 there seems to be just a 7 megahertz rail-to-rail CMOS op-amp. So that's not doing any of the RF stuff. That's not the front end. That's just offsets and stuff like that, bias. That's not part of the signal chain at all. And yeah, due to the placement of these parts down in the bottom corner, I don't expect they're part of the signal chain either. Like that looks like possibly a low dropout reg. So yeah, this op-amp's probably doing offset, but it seems like the signal path is all discrete transistor here. I don't know what an R1A is. Didn't bring my pirate hat. And then you've got all these outside of the metal can here. So all these are outside of the metal can. What the? Why? So these Y2 parts over here, these are just PMP transistors, nothing special. And a 2057 there. The first reference I get is to an LTC 2057, which is a high voltage, low noise, zero drift op-amp. Okay, doesn't make sense because they're usually pretty pricey. Nah, they're just a 1.5 meg gain bandwidth, like it's a real high schmicky, high spec, low bandwidth op-amp. No, there's no reason to have that there, so that's obviously not it. And this AR1A looks to be a LMH6703. Let's go to the videotape. Okay, now we're talking. There you go, 1.2 gig low distortion op-amp with shutdown. So the 6703, that seems to be the, there it is there. Where is that in the chain of things? It's right over here, so maybe our input comes in here and we've got some switch in here and it goes there and then over to here. And these are a differential driver for the ADC, perhaps. Relatively, compared to these days, primitive solution here. You know, nowadays, like the big manufacturers all have their ASIC front ends and stuff like that, right? So you get your 800 megahertz, nice, flat, beautiful schmick analog front end in like single chip almost these days, you know, because the biggies are now rolling their own analog front ends and stuff. So yeah, anyway, I'm not going to reverse engineer that any further. I'll put some high-res photos, of course, as I always do, over on EEVblog.com. Nah, it's just quite an unusual front end. So, yeah, but it seems to be all over the shop. I don't think it's particularly flat. And, yeah, technically, it's 180 megahertz, but it's just like 500 meg samples per second. Okay, you turn on 2 channels, that's 250. Yeah, it's like, I don't know, like a solid, nicely designed 50 megahertz bandwidth front end would have been plenty on a scope of this cost and, you know, class. So, yeah, I don't know why they bother trying to pump these numbers up. And a rough estimate of the current draw, 0.9 amps, so 3,000 milliamp hours. You're going to get a little bit over 3 hours here nominal, so I'm not sure what the spec is, but it's probably around that. And yes, the EEVblog BM036 is available on the EEVblog store, link down below. So there you have it. There's a quick look at this FNIRSI DPOX180H digital phosphor oscilloscope. Thank you very much. 2-channel jobby, like, and for like $130 US on special. I have not surveyed the market. I don't know how it compares with other little sort of like pockety 2 channels, not quite pocket, but you know, like a portable thing that you can like throw in your tool bag. And well, you've got a scope out in the field for, you know, pretty cheap. And well, it is what it is. You know, you've got to like weigh up the pros and cons of this thing. It's not like a high spec scope. You wouldn't have this as your only scope, for example. It's just, you know, designed for like a pocket portable thing out in the field. Although I think a major concern is that technically, like, all you got to do is bump that button and it's on in your tool bag, and when you want to go use it, you've come a gutser. So, yeah, I think they really need to fix that somehow. But anyway, it's an interesting little beast. I think they just try too hard on the specs. Like, you don't need digital phosphor interface. You don't need 180 megahertz bandwidth. You don't even need to even try to do stuff like that. You don't even need to try to have a waveform gen in the thing and that copy over whatever it can capture output over to the signal gen and stuff like that. It's just an absolute waste of time. I don't know why they bother, but anyway, they are cute and they are useful and it does actually work, but just don't expect much from it. So anyway, I'll leave a link down below to the genuine FNIRSI store on AliExpress. You might be able to buy it other places. It's currently on special, so check it out. And you probably wouldn't at full price, the full, what they're claiming is full retail price. You probably, you know, it's not that great, but currently at like 40% off or something like that. I don't know, if you're in the market for a portable little scope, it's maybe. Anyway, links down below. Thanks FNIRSI for sending that in. Catch you next time.